Here we have a unit circle, a circle with radius 1. So just to remind you, unit circle, the radius is equal to 1. So you'll notice you can see the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1 at 0, 90, 180, and 270. Now, if we put one of our special triangles in the unit circle, we're going to have to adjust the radius of the triangle. So we have this triangle, 1 square root of 3, 2, and we have the sine of 30 is 1/2, and the sine of 60 is square root of 3 over 2, and I have the decimal values for those two fractions. But if we're in a unit circle, so let me put this 30-degree triangle here. So if this is 30 degrees right here, then, and this, the radius of this is 1, what are these two sides going to be? So if we were to divide everything by 2 here, then our opposite side is going to be 0.5 and the adjacent side is going to be 0.87. So what I want you to notice here is this distance is 0.5 and this distance here is 0.87. And you can see this by the tick marks on the graph. So this is 1 unit long, so each one of these is 1/10. So 1/10, each of these is 1/10 unit long. So I'm going to actually label them as 0.2, every other one, 0.4, 0.6, and 0.8, because I can't fit all of the labels in, it's too crowded. But you'll notice here that if we go up 1, 2, 3, 4, 5, that's 0.5 right there. And then if we go here on the x-axis, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 8.7. Okay? So that's where we're coming from. And I'm actually going to erase this now because I need to draw some other things on here. But I want you to recognize that now we have created a right triangle, but the sides are the actual cosine and sine values are on the x and y axes. So the coordinates of this point are 0.87, 0.5, where the 0.87 tells me the cosine value and the 0.5 tells me the sine value. So that's how a unit circle works. So I'm going to examine, since I'm talking about the sine graph here, I'm just going to be looking now at the y coordinates. So I have the y coordinate, and I guess I won't erase this because that would be kind of confusing for you guys, but the y coordinate at 30 degrees is 0.5. What's the y coordinate at 45? Well, the y coordinate of the 45-degree angle is going to be, once again, if I divide this by the square root of 2 to get 1, then this is 1 over the square root of 2, which is 0.71. So this distance is actually 0.71, and you can see that looks really logical because there's 0.6 and 0.8. So here y is equal to 0.71. And then if I go in farther to 60 degrees, now 60 degrees is 0.87. So if we go up 1, 2, 3, 4, 5, 6, 7, 8, almost to 0.9, this has a y value is equal to 0.87. And then when we go straight up right here, this has a y value equal to 1. So we start out with y equals 0, then y equals 0.5, 0.7, 1, 0.87, and 1. Those are the sine values for the angles in quadrant 1. So if we go down to our graph here and we say, I'm going to try to get this so you can see both things. There we go. So we're at 0 degrees, the sine value is 0. Then we're at 30 degrees, and our sine value, our y value, is 0.5. When we're at 45 degrees, our y value is 0.71. Then when we get to 60 degrees, we're at 0.87, and then 90 degrees at 1. And so here's the first part of our sine curve. Looks like that. Now, what does it look like in quadrant 2? Well, when we go to quadrant 2, we have the same y values for our triangles as we do in quadrant 1. So 120 is still at 0.87. And 135 has a 45-degree reference angle, so we're still at 0.71 for y. And then when we're at 150, we have a 30-degree reference angle, so we're still at 0.5, and then when we get down to 180, we're at 0 again. So we go back down. We go to 0.87. So in quadrant 2, we're going to go down to 0.87 here at 120 degrees, 150.71, or sorry, 135.71, 150, 0.5, and then we're back down to 0. So there's the other half of our curve going back down. Now when we get to quadrant 2, or quadrant 3, sorry, we have the same numbers, but they're all negative. So we have negative 0.5, negative 0.71, negative 0.87, and we culminate at the bottom at negative 1. And then in quadrant 4, we're going back up. We have another negative 0.87, another negative 0.71, and another negative 0.5, and end up back with y equals 0. Okay, so if we put these points on here, so let me kind of extend this up. It's not what I meant to move. Okay. So kind of looking at the bottom half there. So we have 210, negative 0.5, 225, negative 0.71, 240, negative 0.87, 270, negative 1, 300, negative 0.87, 315, negative 0.71, 330, negative 0.5, and 360 back to 0. Now if you need to pause the video and kind of catch up with graphing, definitely go ahead and do that. I want to point out some key points that are really important to remember. Obviously the points where we're on the x-axis, or sorry, on the x-axis and our high and low points are really important. So it's important to notice that these are very key points. So this is where we're at 90 and 180 and 270 and 360 and 0. Okay, so those are important. And notice that we go up to a high of 1 and a low of negative 1. So positive 1 and negative 1. The other points that are really helpful are the points where our y value is 0.5 or negative 0.5. And notice those happen at 30, 150, 210, and 330. These are all special angles that have a reference angle of 30 degrees. So where sine of theta equals positive or negative 1/2 is at all angles with a 30-degree reference angle. So if you can kind of equate those are points that if you have just those points without the other ones in between, you'll be able to draw a really nice sine curve. Okay, our next video we'll be doing the same thing only with cosine.